Whereas a probabilistic model, events with the identical input, the model the model that we are the output that we are getting may vary from instance to instance. Now here we can gauge the uncertainty or likelihood of the event. It can be any event of probability. If you want to measure the likelihood of anything going up or down in binary sense. Now, in regression models, we use data to estimate the relationship between the mean value of the outcome y and the predictor variable x. So these are the basic models, the beginning models uh, of probabilistic models. Here, the intrinsic value is the raw data which is incorporated into forecast from the regression model. So if you can see that uh, I have taken example of price versus carat range, that is the weight of diamond versus the price of diamond, which we are predicting. So these can come in the regression models.
Dharya, do you have any slide? Because I cannot see it on your screen.
No, Rohit is showing the slides.
Oh, okay.
Oh, but you should be able to see the slides on my screen, right?
Yeah, yeah, now I am. Yeah.
Yeah, that is the only slide.
So in these regression models, there are the first type is the linear regression models. Here's as the name suggests, it's a model which draws a relationship as a straight line. Now we can correlate the equation. Rohit, can you change the slide, please? Now we can correlate this equation of linear regression line with the one which we used to do in a 10 plus 2 with mx y is equal to mx plus c. So here we you can see that beta naught is equal to the c, that is the intercept. Beta 1 is the slope, m part of the line equation. And here what we are having in addition is the error that is being generated by prediction. uh, Rohit, please change the slide. So here is the data of the carat versus price, which I have said. Rohit, it's quite blurred, I suppose. Yeah, it's visible. So here's the mock data that I have collected, which is the price versus weight of diamond, price being the dependent variable. Now, after applying the regression on Excel, these are some of the results. Rohit, next slide, please. So these are some of the results. Here we are having certain key terms which we need to we are have we which we interpret as follows. One is the R square value. Now R square value is the one which tell us how fitted the line is with the regression, how well is the prediction, and how well is the predicted line in correlation with the data which we have given uh, to the inputs for regression. Roy, please change the slide, please.
1 second, Dharya. I want to
Yes.
ask everybody if everybody is following along because I don't know. I have not checked the chat. Firstly, anybody on the call who's seeing this for the first time? There's just 4 of you on the call: Akshat, Deepak, Divyansh, just 3 of you. Anybody who's seeing this for the first time?
No, sir.
Yeah, so all of us know this, right? So then we can go ahead. We need not spend time on this. Dharya, are you okay with this? That we go ahead?
Yes.
Okay.
I suppose everyone is fine
Or
with R square,
1 second,
MSc, and
1 second. Let me ask questions. If Are you guys okay if I ask you questions about this, about linear regression?
Yes, yes, Rohit.
Divyansh, okay?
Yeah, yeah, go ahead.
Akshat also, I'm pretty much sure Akshat is okay. Okay. When we say that we've got this beta 0 and beta 1, so what exactly is beta 0, beta 1? What are those things?
Basically, so these are regression coefficients, and like in normal terms, a line is in simple linear regression. So we have a line y is equal to mx plus c. So the variables here are m uh, and c. So in terms of machine learning, we just rename these as beta components, beta 1, beta 0, and it basically defines a line. So that's it.
No, it says population slope coefficient. So, and population y-intercept. What is population here? Can you see my screen right now?
Divyansh, are you answering the question or?
Anybody
Sorry.
can only Divyansh doesn't have to answer. Anybody can answer. What is the population over here?
So basically, population. So basically, what we are doing is that we have a population where we assume that, let's say, all possible kinds of points, but from that population we draw a sample, and for that sample we fit this line, and we assume that the sample is representing the population.
Okay, now I come to my next question. Now, if we why don't we directly measure the population parameters or the population parameter? Why are we taking the
So,
sample?
so because
So
you
you are
cannot
not audible.
capture. Hello, because you cannot capture the population. So let's say if I want to calculate the average age of Indian nationals, I cannot I can obviously collect the data for all the people that are there in India, but it I would assume that I would pick samples from different demographics, and I would calculate the average, and I would assume that this is representing the population.
That's wonderful, Deepak. That's wonderful. And in certain cases, is it not possible to capture the entire population parameters? So maybe yes. So okay, fine. That is okay. So that's a different question. Now, in this case, you know uh, what is being explained here, the weight in carats and the price in Singapore dollars. What is the independent variable? This capital X, which is the here. What is the independent variable? Can you hear me?
So I can answer, but I just don't want to answer all the questions.
Divyansh, Utkarsh, sorry, Utkarsh, Akshat. What in this? What you can see the Excel sheet in front of you, Excel sheet screenshot. Which is the independent variable?
So the weight.
Okay. Why is the weight the independent variable, and why is this other one the dependent variable?
So the weight is something that we are selecting, right? The carrots is what we want to manufacture or something like that, and the price is depending on the weight. So clearly, weight is the independent variable, and price is the
Perfect.
dependent.
Yeah, that's correct. Okay. Now, within this situation, or let's say in a generic situation, what will be this epsilon? So, random error component. What exactly is this epsilon, and why is it here?
So epsilon is basically the error coefficient that we measure. So there are many ways and many things that we can do for calculating this epsilon. It's basically, in simple terms, you can say the offset value that we can get in a linear regression model. So the line may be, maybe perfectly aligning with the data points, but it might be offset.
No, I'm not
few coordinate.
trying to understand from a practical point of view. In this situation, there are weights, okay, in carat, which is weight is just like kg, gram, whatever, So this is carat, so no big deal. We understand weights, and basis that we are saying there is price in Singapore dollars. It can be US dollar, it can be INR, whatever. So this is a very simple thing that we are seeing in front of us. There is nothing very complicated here. So what I'm trying to understand is in this Excel sheet or otherwise in a practical situation like this, what is this epsilon? What is the error? Random error term? What exactly is this?
So Rohit, this error is basically the sum of all the residuals. So basically, you have the actual value of the price of the price. So this error term is basically sum of all the differences between actual price and the predicted price across all data points.
So there is this correct? Is this how we should understand it?
See, according to me, it's a standard deviation of the residue, the spread of the points about the fixed regression line.
So is this related to something over here, the RMSC and all that? This
Yes,
mean
yes,
square.
yes.
So that's exactly what I there. Uh,
Okay. So that means we all have understood these first two slides. Okay, this we have understood. And this we have understood. Right. And now we are predicting the dependent variable over here. So what if we were to predict the y hat? What is the y hat? How does that get predicted? What happens? I didn't see y hat anywhere on this PPT. Anywhere on this PPT. What is that y hat?
so
So there
the
are
y hat is this only.
no.
Y I. So are you
See,
meaning that y cap is the actual value
no. One second.
or the predict?
It is not the actual values. That is also predicted only, but
Yeah.
the representation is different. So what is the difference between the estimated simple linear regression equation, which is ESLRE, and the simple linear regression equation, and this what you call the simple linear regression model? So what we are seeing in front of us, the model, what is the equation, and then what is the estimated simple linear regression equation, and calling it estimated, what is the population and the sample thing that we discussed in the beginning. So all that understanding we need to have. Dharya, can you give us that understanding now? Could you guys hear me? What I'm saying?
Yes, sir. Now it's clear.
Yeah. So we need to understand those differences, na? Okay, what is the estimated simple linear regression equation, and why are they calling it estimated? And what is simple linear regression equation? Why does the word estimated come in the middle, or right in the beginning of this, whatever? So that's okay. So Dharya, you please the way we are going, I'm sure you will cover this somewhere. Now over here, the multiple R, the R square, adjusted R square, what exactly is this? What is this standard error? The standard error has got something to do with what is ANOVA? So all these things we need to understand. What is T stat? What is P value? P value is a point estimate. Then is a P point estimate good for what kind of this thing? It is not good for what things? All these things we need to understand. Divyansh,
Yes, sir.
if we don't understand all of this in the Excel only, then coding it will be a problem.
Yeah.
So we should be very very clear what is happening in this, especially in this thing slide. Dharya, you agree with me? Where is Dharya? Dharya, can you hear me? I am not saying this is Dharya's responsibility to explain all of this to us. These are things which are either we are already aware or we should be aware. Because if we are not aware, then there can be an issue later on. Dharya, you please continue with the PPT if you can hear me.
Sorry, Rohit, I've joined again.
Yeah, I can hear you now. I'll go to the slides. You please continue with the presentation.
Uh, it was the next slide, I suppose, the R square values and MSE. So I suppose that I've completed this R square. It's just that it tells how much fitted the line of regression is. So most probably we try our values of R square to be higher, but it's not always that we want our value to be high. It can a higher value uh, can be an overfitting also.
See this second line over here on this slide, which says this statistic indicates the percentage of the variance in the dependent variable that the independent variables explain collectively. Now this I want all of you to focus on and tell me what is this explain collectively का क्या मतलब है यहाँ पर. I just had a call with Abhiroop Chatraj, and Abhiroop is trying to tell me that the explainability of this thing model has got to do with him trying to explain to somebody in business कि यार मैंने ये क्यों किया वो क्यों किया. That is not what it is. This is English being written so that we can understand statistically what it means. So when it says a statistic indicates the percentage of variance in the dependent variable that the independent variables explain uh, collectively. So certain independent variable will explain the variability more, and certain other independent variable will explain the variability less. Right, and that is what the explanation of the model and variability and other things over here mean. So Aviroop did not understand this, so I told him to understand it and come back. So I don't know, whenever he does that PCA, so this is where the PCA and the factor analysis and dimensionality reduction and all of that comes into play. Okay, am I right or am I wrong?
Yes.
Yeah, so this is very important for us to understand. If we say we want to reduce the dimension of a data set that comes to us, like what Divyansh has done now, Divyansh has given us the function to end up loading a CSV which people will load. They will load a CSV of 90 columns or 99 columns, and they will expect something to happen, and people will do that. But this line is important for those people to understand that you probably will have to do a factor analysis, and factor analysis within factor analysis, the PCA is the most common way of doing that dimensionality reduction, and 90 column this thing what you call a table, SQL table or a CSV is not okay for doing any kind of statistics on that. So they need to reduce the dimensions. Yeah, so this we need to understand. And the R square measures the strength of the relationship between your model and the dependent variable on a convenient 0 to perfect. Yeah, please go ahead.
So the next one is the mean square error. Here we will all know that we'll be using libraries for regression. In there, there's one common method, that is ordinary least square. It's the same statistical key point, mean square error. So OLS is so it is nothing. It just calculates the average. It is just calculated by averaging the square difference between the real data points and the predicted outcomes. Rohit, can you please change the slide? Now, wait a second, please. The last slide.
I'm on the MSc slide. This one?
Yes, this one, this one.
Okay, sorry.
This was in the R square slide. So the points which are above and below, these all points are having a certain distance from the regression line. Now, basically, what that R square value meant was that how closely these points are to the regression line that we have computed. This was all I wanted to tell in the R square. Next slide, please, Rohit. So it's the mean, as I've explained, that it's mean square error. It's the average between the real data points and the predicted outcomes. So for its formula is, Rohit, can you please change? So it's, as you can see that it is uh, a summation of all the yi is all the actual outputs that we have got, and the yi bar is the predicted outcomes that we have predicted, and we'll be summing all these up and having an average of them. Now, one key point to note is that the when we calculate MSE, the the uh, the value or the variable that we were using, all of these get squared. Rohit, should I skip to next slide?
There, which slide you want? This one or the next one?
No, Rohit. There was Divyansh was saying that we all know this. So I was asking that if we can change
Oh,
the
sorry,
slide.
I didn't know I didn't see the chat. I'm sorry. Yeah. So now, which slide?
But then I think we should go to logistic regression.
On the C, multiple regression and these things. If you can give us some examples from the finance domain, so those I am sure none of us we know. We'll be interested in knowing that.
For let me think.
Okay, it's okay. We can go to logistics.
It's not particularly not from finance, but something. It's like the fuel economy of a car. It can depend on the weight of the car, or it can also depend upon the climatic environment of the climates or the environment in which the car is a car in which we are driving the car. So it can have uh, multiple points of independent variables. Hello.
That's okay. Divyansh, any questions, or anybody else any questions? We can move to logistic regression otherwise.
Yes, so we can move on.
So logistic regression is also the one of the most common algos that we are using for the binary classification. Now it predicts the probability of occurrence of a binary outcome. It's going to be either 0 or 1. It's going to be a probabilistic way of finding if something is uh, in a certain boundary or not. So for it we use a logarithm logistic function. So it can be considered as the special case of linear regression, as it is going to predict the probabilities, but with a with a special function of this of the logistic or the sigmoid. Uh, Basically, we can use these functions in cancer detection or the fraud detection or spam detection of in our emails or anything that we have in relation to it. Now, what is sigmoid function? Rohit, can you please change the slide? So it's basically this 1 plus e to the power y. That is the sigmoid function. Basically, what is it is doing is that it is calibrating. It is transforming that our regression from a linear one to an S shape. That is why we are saying it a sigmoid. It's a correlation to that, uh, and it's going to map the real values and the outputs accordingly to this function. Rohit, please change this next slide. So it's all everything that I've covered, that it's a probabilistic function, and it is going to be somewhere between 0 or 1, where you can categorize it. Either something is inbound to a certain criteria, or it is something or something that is outbound to a certain criteria or inference that we have set. Rohit, please change the slide.
I have a question here. So the cost function,
Mhm.
I have read many places that what we are trying to do is we are trying to reduce the cost, or trying to reduce the cost function. What does that mean?
So basically, it's like the performance of that graph, how well it is judging or the errors in it.
Does anybody else, uh, I've read it in many places that we are trying to reduce the cost. So that is the main purpose that we
Yes.
have.
So in any ML model that we have or that we train, so we always focus on reducing the cost function. The cost function it's simply basically the error values that we get. So we have predicted, say in linear regression, we have predicted a line, and fitting that model over the data set, we get errors. So our main job is to tune the parameters in such a way that we get the least errors and a line is best fit. So reducing the cost function basically means to get a best fit line, which can cover up all the data sets, data points, and so we do this generally by gradient descent and stuff like that. So that's the whole thing behind cost function and reducing the cost function.
So when you say gradient descent and all that things, and you left it there, are you relating the sigmoid logistic regression, this thing, to something to do with the neural networks? Is there a connection over there?
Not generally. It's not nothing like that. We need to dive into neural nets at this point. It is basically a simple equation again, which will tune the values to have a best fit line. So having a less low cost function is better fit for the plot. That's the mapping between cost function and the line of regression.
No, that's okay. I agree with that. We don't need to go towards the neural net, but within the neural network, there is again the sigmoid which is there. So, are we at least aware of that, or is what I want to understand from everybody on the call? Are we kind of aware of this? Yeah, so Akshat is mentioning that it helps the learner to correct change behavior to minimize mistakes. Uh, yeah, so see, within the basic neural network, which was, the some of the most, let me say, ancient neural networks before TensorFlow and Keras and PyTorch took things over, and before we really jumped into deep learning and all. The logistic regression or sigmoid function is very much a part of that. So that is there. Now, I might not be able to explain it because I'm not an expert on this. But that is how it is, classifying ultimately. Uh, and now, how the relu or something else is much better, and why it has got replaced, and why people don't necessarily use sigmoid in today's date. There is a different there is quite there's quite a lot of theory about it and other things, which I did read sometime, but now I don't remember, so I unfortunately can't explain that. But yes, this is the connection between logistic regression statistics and I'm getting a call from somebody, so I don't know who it is. I'll have to take this call because third time the person is calling me again. I have no idea who it is. Give me a second. Maybe.
Hello, hello. Can anyone hear me? Hello.
Yeah, yeah, we can hear you.
So is the meeting ongoing or what? As in nobody is presenting.
Rohit had a call. I guess he'll join back.